Hello, good morning, and welcome to the Signpost Series webinar today, Friday, the 21st of February already. And thanks very much to everyone for joining this morning on what is a miserable morning in the southeast of the country. I'm not too sure if it's the same elsewhere, but certainly I came from close to Tullow across the Oak Park this morning because our power is out. I hope it doesn't stay out as long as it did after the recent big storm that crossed the country, but I think it's an example, more examples of changing weather patterns that are happening across the world. And with that in mind, we have this morning speaking Dr. Elodie Ruelle on climate adaptation in Grassland. So good morning, Elodie.
Hello.
And also with us this morning to help with the questions is Seamus Kearney, who's the Climate Sustainability Advisor working with Teagasc, whose area would be measuring the contribution of agriculture on farms to climate change, but also advising farmers on resilient actions with regard to what they can do to be best set up in a changing climate with intensifying actions. So Elodie, thanks very much for joining us today. Our paths are crossing quite a lot recently. I know you work largely with modelling of grass growth and grass prediction models, and I know from my own work in the agricultural catchments programme that changing climate is having a big impact on water quality. Water quality and what it is a result of biological processes, which grass growth is no different. And I think there's an awful lot of line there. So I'll hand you over to introduce yourself, and I won't stop anymore. I'll let you carry on straight into your presentation from there.
Okay, brilliant. Okay, I'm gonna share my screen first, like that it's done. And yeah, so thanks for that, Eddie. So my name is Elodie Ruelle. I'm a senior research officer in Teagasc Moorpark. As Eddie has said there, I'm a modeler, so I work mainly with, trying to do projection, trying to predict grass growth prediction, nitrogen leaching, a lot of different things, also on animal intake and so on. And since few years, I guess a good bit of my work is now more in the direction of climate adaptation and how can we better adapt in the future. So that's what I'm going to try to present to you today. So I want to thank the co-author, so some colleagues which helped me with some of my slides to give you a bit more information for today. So first of all, I guess, sorry, one question I always get is what really is climate adaptation, and is it the same as mitigation? Is there a difference between mitigation and adaptation and so on? And yes, it's the same thing. And I guess for the last few years in the past, we have all the research has really been focusing on mitigation. And mitigation is really trying to reduce the impact we have on the environment to reduce the future climate change. So mitigation is reducing greenhouse gases, it's reducing nitrogen leaching, and it's all that. But good mitigation strategy doesn't mean that you're going to be prepared for the future weather, which is going to happen and which is going to come. So adaptation is really trying to have systems which are resilient in the future weather or even in the current weather we're having. And I guess adaptation is really happening currently every day on farm. If you're a farmer, you're doing your farm work, you're looking at your data, and you realize you don't have enough grass, or you're starting to be in grass deficit, and you take the decision to put, silage in the diet of your animal. Technically, that's adapting to the climate to the weather in front of you. So that's really, it is happening, and farmers are resilient to it. In terms of research, I guess for me, it's trying to increase the resilience of the farms to the current and the future weather. So that's what we're going to look into it today. But, it's very hard to adapt to the future if you have really no idea at what's going to happen. So that's why in my presentation, I will start to do some kind of grass growth projection of what might happen in the future, in the near or far away future. And then we're going to look at how can we adapt to that possible change in grass growth. So, excuse me. So to be able to predict future growth, what do you need? You need different things. You need a model, which in Ireland we have a model which is fairly good and which we use to do the grass growth prediction at farm level weekly, which is the most grass growth model. So it's fairly as we know, it's working at the minute on farm across the country to predict grass growth. It should be good enough to be able to project future growth. You need some hypothesis simplification. So here we're going to just consider in that presentation that we're just going to look at free draining soil. So that's early work that I'm showing. So we'll have to keep working on it and to do different type of soil. And we're going to apply a fixed amount of fertilizer. And then we need weather projection, which are going to show us what's going to happen in the future in terms of weather. And for that, there is a very good thing in Ireland, which is done by Meteran, which is called the Translate project, and which gave us exactly those kind of data for the future. So there is two types of simulation we can do. And the first one we're going to look actually at the full country at the resolution of 1 kilometer square. And we're going to look at an average year, either in terms of grass growth, so historical growth, or either what would be the consequences of grass growth on the Earth warming of 1.5 degrees or of the Earth warming of 3.0 degrees. Okay, so that's what we're going to look first, and that's an average year for each of the small 1 kilometer square of the country. And then we're going to look more at specific location. So and before I show that, so basically, if we look in terms of weather projection, what it's showing, it seems to be showing in average, we should get even more rain in the autumn and winter and in the spring. So more rain there. In average, more temperature all across the year and a bit more drought weather in the summer. That's what the weather projection looked like. So if you put that into the grass growth model, what is it showing? So that's your historical map. The model is predicting a grass growth of 12.4 tons of dry matter per hectare in average, which would be possible. And the darker the map gets, the more grass growth the model would be predicting. In terms of annual growth, if we go to 1.5 degree warming in average, so Earth warming, then what happens is actually you do get an increase of growth. And if you go to the 3 degree warming, you get another increase of growth. So it looks fairly positive. From those maps, it's a bit hard to know if it's everywhere in the country or not. So what I've done is I've done basically the grass growth projected for the 1.5 minus the historical to see if there is some part of the country which are decreasing. And that's the new map that you can see there. Sorry. So basically, if it's green, if any color which is blue or green means that there is an increase of grass growth, and anything which is white or brown means that there is a decrease in grass growth. And if you can't really see, believe me, everything overall is blue. There is no yellow, there is no brown. So if you look at the 1.5 minus the historical, you do have an increase, which is around 3.6% increase. And you can see if you do 3 degree minus historical, everything is still blue, and you have a 8.6% increase. And then if you do even the 3 degree minus 1.5, so it's this map minus that map, you still have no yellow, no brown. Everything is show an increase in grass growth. And what we can see also is if you look at the first map on the left and you compare it to the map on the right has way darker color. So that means that the difference will be higher, like the increase of growth technically should be higher between the 1.5 to 3 degree warming than between the historical and the 1.5. So that means that the increase in growth, that will, go faster and faster up to 3 degree anyway. We haven't looked further than that. So if we stop there, I guess what we could say is that, climate change looks positive. There's more growth everywhere. The growth keep increasing from 1.5 to 3 degree. So, we could stop there and be very happy. But what we need to look at is when is actually that increase of growth. So what I've done is I have redone those maps, the one on the bottom, and I have done them by monthly grass growth, so the monthly difference. And that's what you're getting. So here you have the different months of the year. I have hidden some. And I'm doing the difference between the 1.5 Earth warming minus the historical grass growth that the model would have predicted. What you can see, so it's the same like shard color. So anything which is blue and green, once again, means an increase. And anything which is yellow or brown means a decrease. So you can start to see Overall, for those months, it's an increase a bit everywhere. You do see some shape which are a small decrease in growth, a small bit of yellow, especially in the west there. And October, November, December look like an increase everywhere. Now, for the months I haven't shown you, it's a bit different, obviously. So what you can see, especially in July and August, and a bit September also, but July and August are the bigger one. You start to see a decrease in growth for those months, especially on the east of the country and in the Midland. Okay, that's the 1.5 minus the historical. Now, if we go to the next step and we look at the consequences of the 3-degree Earth warming compared to what we had in terms of historical growth, sorry, that's what we can see here. Basically, it's the same story, but way more intense. All the color are more intense. So what you can see, it's predicting a very big increase for April, up to 400 kilograms of dry matter more for April. So that's what it's 1230 kg of dry matter per day increase. So it's fairly high. But then once again, especially for the east of the country, for August, you have minus 400. So here you start to get, a good bit of change in seasonality in between. And in September also, you start to have a decrease of growth, which is the consequences of the August one. And the last map I want to show is the 3 minus the 1.5. So the difference between 1.5 Earth warming to 3 degree. So that would be this map. And if I go back to the first one, it's just to show the difference in color. So we had this between historical and 1.5. And this for 1.5 to 3. So once again, 1.5 to 3, you have way more intense color. And what that means is that, once again, the change in the direction of the grass growth, we'll say, will be more intense if Earth keeps warming more and more. So for the full Ireland simulation, it seems that there is a small increase in growth, and there's a big enough change in seasonality, but which is variable depending you are in the country. That's why it's always very important to, when we look at solution, when we look at projecting things, to look at different location and not just one. But all that was only an average standard year. So what about variation between years? So that's what we're going to show after. And also that increase of growth was possible because I was still putting as much fertilizer at the same time and so on. Realistically, if trafficability is too bad in the spring and you can't put fertilizer anymore at that time, that increase of growth wouldn't happen. So that's things we need to consider also. Then, so we're going to look at specific location. So for that, I took 2 locations, and for once I didn't took Moore Park to change a bit things. So I've took Ballyhaise and Oak Park in terms of location. So Ballyhaise and Carlow at different time series. So we're not speaking in Earth warming anymore. We're speaking of possible future. So we have the historical, then 2035 in average, 2055 in average, and 2085 in average. So we're going fairly far into the future there. We are taking a climate change scenario, which is fairly negative, but which is still sadly possible. And the extreme years are more realistic in the 8.5. So that's why I took that climate change scenario, which is, a bit negative. And then 6 weather models. So when you start to look at really specific location, basically Meteran will give you different possible future. Here I have 6 possible different ones, which apparently are all as likely as the other. And technically you have 26, but I haven't done the 26 yet, and 6 is more than enough to make a point. So that's a lot of simulation. Anyway, so that's how I'm going to present the result now. You have annual, so that's the annual growth. You have Ballyhaise on the left, Oak Park on the right. The big red box was the range of the grass growth, annual grass growth in the past. And then all the different color correspond to a different weather, possible future weather, and the size of, and that's the first box I'm showing you there are for 2035. I've put it 2 green line to try to see if we can see a bit more things. And here, I don't know, the model don't really agree for Oak Park. Ballyhaise, the box seems to start to go a bit higher, but it's hard to know. If you go to 2055, once again, Ballyhaise keep going a bit higher. Oak Park is very hard to know. Most of the box, though, in Oak Park, you can see are starting to get larger and larger with or higher box, like bigger box. So that could mean that the variability between year will increase. But even like that, not all the models are agreeing. And then finally, 2085, that's when you start to have some very negative model there, but still it's very messy. So for me, in terms of annual growth with those kind of simulation, it's very hard to draw any conclusion. And there's possibly some increase in extreme year, in extreme bad year, with those dots being a bit more present there than they were before. But even like that, I find that very hard to know. So no real answer when I look at this like that. But I'm going to look again at the monthly data. And in terms of monthly data, so if I look at the month of April, for example, to go back to what we have seen before, well, here, so it's Ballyhay still on the left, Oak Park on the right. You can see that historically, the model is predicting that Oak Park is growing a bit more than Ballyhay in April, which kind of makes sense, so that's good. And what you can see is 2035, most of the box start to going up, except for one of the weather model there. And for Oak Park, kind of all the box start to be going up. So increase of growth in April, which is getting bigger for the further future, 2055, and which is getting even bigger for 2085. So that seems to be agreeing with the, overall full island simulation, and there seems to be at different location, an increase for the growth in April. And then now, if we could look again to August, then the story is a bit different. So the model is predicting a higher growth in August for Ballyhay than in Oak Park. So that makes sense again. So that's always good when the model makes sense that way. And then you start to see a decrease, which is possibly way bigger to Oak Park. It's one of the models which stay positive, but all the other ones start to go down. And the further away you go, the more all those models start to go down. And even for Ballyhay, that's the same. So that's your possible coming as more drought in the summer. And what you can see also is like the size of the box there. You have a fairly small range here of growth in August in the past for both Ballyhay and Oak Park. And you can see the further away you go, the more the size of the box and kind of all the model agree on that get bigger, and especially for Oak Park. So what that means is there's going to be a way bigger variability in the months of August of grass growth in the future. And I guess, we're starting to see that every year is different from the previous one now, and than before they were always the same one. So, that's really the takeout of that, of all those simulations. There's an increase in variation between year and a possible bigger reduction of growth in Oak Park compared to Ballyhay. Okay, so in conclusion, still a lot of things to go through, but conclusion of the simulation, so what? Because there isn't that much variation, that much difference in what I'm showing you so far, and what can we do about it? So we have a project which is funded by DAFM, looking at adaptation strategy, which have been published for the grassland sector, which would be relevant for future weather in Ireland. And doing a lit review, so I have a postdoctoral researcher, which is doing a lit review on that, and it's not very easy to do a lit review when there's very little things published on it. So I'm just going to show you the first few results of what she found and what we can do, So the first thing I've shown you is there's no major change in annual yield with possibly steady increase, but that increase is in spring and autumn mainly, and not during the main grazing season. And if in the projection Meteorite are right, and there is also an increase in terms of rainfall during those periods, how are we going to be able to use that extra grass without poaching everything and damaging the grass? And if we do that, that means all the increase of growth won't happen. So how can we graze in terms of bad trafficability? And so there have been a good bit of work done here in Moore Park. So what are the factors which are affecting poaching? As the severity of poaching, coarse size, we're not going to go down that road. Soil structure, we're not going to change our soil type. Stocking rate, we're not going to change that much either. But grazing duration is one thing we can play with. So there's been a good bit of work to do on on-off grazing. And I guess traditionally, when we had bad trafficability, there was two main solutions: either keep the cows indoor full-time on grass silage, or put the cows outdoor by day, and then you bring them back by night. What has been done on-off grazing. It's trying to look at how are the cows actually grazing normally. And they do graze for 9 to 10 hours normally, and in 2 grazing booths, in 2 times. And there's large amount during the day there, as you can see, where they are not grazing, and that's when they would damage the paddock. So the idea behind on-off grazing is really to make the cow graze when they would normally graze and bring them back in when they aren't teating. So the idea is basically you have 2 milking, you let the cow outside 3 hours just after each milking, and you bring them back indoor after. I'm not going to show you the results. There's a lot of paper published on that, but overall, on-off grazing did work very well on all the experiments we had. There was no reduction in milk production compared to if the cows had full-time access. So there they had only 6-hour access, 3 hours after each milking. There was no reduction in milk production compared to full-time access. They did achieve 97% of dry matter intake compared to when they were restricted, compared to if they were full-time outdoor. And they didn't require extra supplementation. So that milk production not changing, it wasn't due to extra supplementation when they were back indoor. Okay. So on-off grazing do work well, but that does mean you need very good farm infrastructure to be able to do that. And also that means realistically, if you have to do it more during the autumn or the spring, you probably need more slurry storage also, because that means your animals spend more time indoor than if they were full-time grazing. So we need to think about that. After, the other big thing of the simulation did show that there would be a big increase in variability, especially for the summer months. And what can we do about that? So if you look at the literature and you look at what we can do in terms of drought and what's better in terms of drought timing, multi-species do look like a fairly solid solution. And if you look at the literature, sorry, if you do look at the literature, there is all those benefits. So there are better drought resilience of multi-species, better yield stability, which is exactly what we want in terms of when the variability should increase in the future, better post-drought recovery. You have efficient resource use, so you need less nitrogen because there is clover in them, and they improve forage quality. So it's kind of everything we need in terms of adaptation for the grassland system, but I am going to put a but on it. When you really look deeply in the literature and you look at the paper which have been done in terms of climate adaptation, I'm not speaking about production or anything, but really all the paper done on drought, we'll say, they were all conducted in plots or glasshouse under cutting regime. None of those paper were done in grazing systems. So that's a bit of a limitation on that. All the Irish drought experiment were done in Johnston Castle, and they are very nice paper, but we need to test them a bit on different soil type at different location to see if the result which worked in Johnston Castle, which work on different location in Ireland. There hasn't been any research to date looking at, the impact of rainfall in the winter, and so that could have a negative effect on the multi-species, maybe more than on the grass. And also the big point with multi-species that you hear a lot is around persistency. And most of the research which has been done so far, it's always done on the first 3 years after sowing the multi-species. So we need to look at, do those benefits still happen on long-term experiments? And I guess my big disappointment last year was, so there is system experiments which are not done to look at drought and so on, but which are there in different Teagasc farm and also on Lions farm. So in Curtin, there is a system experiment around multi-species, and there is a lot of positive in terms of animal benefits and so on. And we try to look at, last year, it was fairly dry. So that was a perfect year in the summer for the multi-species to be growing more than the grass and the grass clover treatment, and they didn't grow more. They didn't grow less either, so it wasn't negative to have them there, but that was really the good year for the multi-species to show that they would be a good adaptation strategy, and it didn't work as well as what I would be hoping. So we're missing something. Why is it working on cutting experiment and not on grazing? I don't know. We need to find out why. But yeah, there's more work needed, but I still think that, you know, in the future, there will be a good adaptation strategy. We just need to find what we are missing. Okay, then if we go back at the variability between year, that means we're gonna get more summer drought. That means we need more buffer feed. So that means we need more silage, silage stock in the farm. And by meaning more silage stock, we need good quality silage because, you know, traditionally, when you're feeding silage to your animal, it will be more in the winter when the animal are dried. And now we're speaking at feeding silage and more silage to the animal during lactation. So we need good quality silage to be there, and we need more stock of it. After, one adaptation strategy that a lot of people are already doing is actually measuring grass. Because when you measure grass, you will be able to see faster that variability between year. You will be able to see faster when you're going to be running out of grass or when you have too much grass. So that's very important. I think, you know, grass measurement will become more and more important in the future. And then, okay, finally, we do have the grass growth prediction. So hopefully that's another step in the adaptation, and we'll keep trying to improve the grass growth prediction model to give weekly prediction to everyone in terms of grass growth they're going to grow for the next, for the coming week. So we are going to keep doing that, and hopefully, if we get better and better, that will help people to be able to see that variation coming faster and to be more prepared to take the right action earlier on. And my last point really on what can we do, and that's not just for future weather, it's for current weather, but that will become more and more important. It is to have the right stocking rate for your weather, for your location, for your soil type, for the grass you're able to grow. So I did, so I'm a modeler, so I did a small modeling exercise here. And what I did 2 different soil types, heavy soil or free draining soil, and I've used either the weather from Ballyhaise and Oak Park because they are fairly different. So, you know, Oak Park is way more droughty. There's more drought in Oak Park. Ballyhaise is more heavy soil and more rainfall. And what I want to show is what would be the optimal stocking rate for the different system based on what the model is predicting. So I'm going to show 4 graphs like that. What you can see on that graph is the green line here is the grass growth in kilogram of dry matter per cow, just easier to compare everything. So that's your grass growth curve. And then it's I've used an average of 12 years of data. So I have run the model to 12 years of data. And so that's the average of the 12 years. The gray all here, so that's the weekly feed of the animal, basically. The gray is the concentrate feeding, and that was fixed. The black is when the cows actually were eating indoor, so that means trafficability was too poor. So the cow had to go back indoor because there wasn't enough feed. Because they couldn't graze anymore because there was too much water on the field. Trafficability wasn't good enough. The green means grass intake, so that means the cows are outside eating grass, and the brown you don't really see in that simulation is when silage was fed outdoor because there wasn't enough grass, but you could still be grazing. Okay, so on that one you had the 13.1 ton there is the average grass growth, well, the annual yield in terms of grass growth, and the 2.26 is the optimal stocking rate that I could have to be perfect for that farm. And what you can see, so here you see there's a lot of blacks because it's Ballyhaise with an heavy soil, which is probably what they have. So there was a lot of time where trafficability wasn't good enough. If Ballyhaise had a free draining soil, that gives you this graph. So here you're growing 13.2 ton, so fairly similar grass growth. But what you can see here is there's way less black because you can graze for way longer, and you have more brown because you can feed silage and graze at the same time a bit later on. And what you can see is there is way more green. So there is way more grass going directly into your animal. And that gives me an optimal stocking rate for that one of 2.4 co per hectare. So they are growing almost the same, but you actually can keep more cows because you can put your grass utilization basically is higher. Then if you look at Oak Park with a free draining soil, so there they are growing less, 12.8 ton, and you can see the grass growth curve. There's a decrease of growth in the summer there. And way more green technically than here, lots of green, silage is needed, and you can have 2.33 co per hectare because, well, you're growing less due to the summer drought. And then if Oak Park had an heavy soil, well, then, it would be very good. They could grow 14 tons because the weather would be fairly good for Oak Park than there. And, there's way less black on the right compared to the left. So you could have actually a stocking rate, which would be the highest of all of them, of 2.49 co per hectare. And that's really all those variations are really due to grass utilization and how much grass we can have. So, and I think what I want to show there is like when you're calculating, you're trying to think what is my optimal stocking rate for my system. It's not just location or it's not just soil type. It's really a mix about everything and what are you able to do within your farm. Okay, the last thing I want to talk a bit about is a project we're starting, which is funded also by DAFM, which is the Agri-Adapt project. And the idea is really, it's cross-sectoral, so it's not only the grassland, and the idea is to try to develop a strategy for the Irish agriculture to adapt to climate change. Okay, so the first part will be doing a bit what I've shown at the start of the presentation, to projection in terms of the impact of climate change for grassland, crops, and forestry. And the second one I want to talk a small bit more is around grass diseases, and that's thanks for Ella for giving me that slide. Because grass diseases for the moment in Ireland, I guess, hasn't been really a concern. And why is that? Is because how diseases occur, higher temperature increase, the likelihood of grass diseases, and high humidity also. And I guess, so that means in future climate, we have more chance to have more grass disease due to that higher temperature. And the current adaptation are actually a lot around putting higher nitrogen on the plants. So what that means is that in the future, we have higher temperature and we can put less nitrogen due to, a lot of different policy and so on. Well, maybe we will get more grass and grass diseases. So we need to be careful about that and to start thinking about it. So part of the project is going to start to look a bit at that. And I guess in the future, so what can we do about it? That will be probably breeding selection, having the grass which are disease resistant in the future. We might have to work a bit more on that. Okay. We're going to look also in this project through an abandonment cost curve. So, okay, we're going to develop adaptation strategy, which we think makes sense, but we're going to look at, do they make economic sense also? We're going to look at BYDV, so for the crop side, so I won't go too much near it. And then we're going to keep developing decision support tools and have some kind of warnings in terms of weather warnings, grass related. So, we have pasture-based Ireland at the minute. We have already the most grass growth model, which now is into pasture-based, which do grass growth prediction for 84 farms. We're going to try to increase that number to more farms, I would say, this year, and keep improving the model. But what we want to do also is have, at some stage, maybe some trafficability predictor based on a paddock by paddock basics. And that could be linked to weather forecast. And, you could get warnings saying, graze this paddock today, because otherwise, if the forecast is right, you won't be able to graze it for the next 2 weeks or something like that. The thing I would really love to do, but that's that's very complicated, is nitrogen fertilizer recommendation. So with the model and so on, are we able to know how much nitrogen is still in the soil? And then you could give specific recommendation paddock by paddock level on when and how much fertilizer you should put on each paddock, but we're not here yet. And then finally, that's a collaboration with Meteran, and we'll hope to do some kind of national warning. So the same way that you have blight warning, can we have drought warnings, nitrogen leaching warnings, and so on, and maybe grass disease warning also. And that could be incorporated into Meteran farming commentary or their website and so on. Okay, so I'm now at my conclusion, I guess. So for me, I haven't pushed on that point enough, but what I was trying to show at the start is that the better we're at mitigation, so the less we're going to have global warming, the less, or climate change, the less we're going to, have greenhouse gases and so on, the less we'll need adaptation. So basically, the better my colleagues are in the mitigation department, the less my work will be complicated. So we need to keep, mitigation is very important. It's hard to know exactly what's going to happen in the future, but what we know is that we need to build resilience in the agricultural systems. And in terms of dairy sector or grassland, what does it mean is having the right stocking rate for your system, massively important, and having more buffer feed, more flexibility around your system. And that goes through the right stocking rate. One solution won't fit all, so we need to look at the right measure for the right location, depending on the soil type of the weather over there, and so on. That has to be farm specific. We can't just have a general answer anymore. So yeah, the change in grass growth pattern seems to be limited, it's not that big, but the increase of variability definitely will be the challenge. From my point of view now, I do think that at least at the start, the higher rainfall and the poor trafficability might be a bigger challenge than the drought. And we might have not that much drought at the start, but we're going to have more and more year where, either the spring or autumn are a challenge. And I think we have seen that in the last few years. There is very little work so far, which seems to have been done on climate adaptation, but we're getting there. And I guess, I thought it was only in Ireland, but the other countries are doing even less work on it than us. So, we're starting, and there is work which are done and which could be considered as adaptation strategy, but they are not called that way. So we just need to find them. And yeah, so some solutions I just say do exist, but for lots of them, we still need more research, not researcher, but more research to be done. Yeah, and thank you.
Elodie, thank you very much. Just before we go back, I forgot to say at the start, and actually at this stage, the Signpost series running so long, maybe it's not necessary, but I will encourage people to put questions into the Q&A function on Zoom. There are a number in there already, but do keep them running, and we'll do our best to get answers to them. Elodie, one that has come in, and I think you did answer it throughout the presentation, but just to be clear, and not assume the obvious, but when you were showing the national trend and where the grass growth levels during the summer months was decreasing, I assume that's because of drought.
Yeah, 100%. Yeah. So it was due to a bit of water deficit and higher temperature. So the two combined together would lead to more drought. So it's not just one or the other; it's a combination of the two. Yeah.
The combination of the two. And on the other side of it, you expressed there in your summary at the end that trafficability and ground conditions is probably going to be a bigger concern, or certainly is a significant concern. One comment came in that work being done in the north of Ireland is using agroforestry, and there seems to be observing good benefits with regard to trafficability because of the moisture being taken out of the ground with combined agro.
Well, a couple of questions already, just for Elodie, maybe. First one, Elodie, is in general, people said excellent presentation. So I suppose the temperature seems to be a significant driver of grass growth. So can fertilizer input be reduced at the same and the same grass growth yield be achieved into the future? And I suppose, are those grass growth predictions on a constant fertilizer input?
So they were on a constant fertilizer input. So I guess if you do reduce the fertilizer in, you might go back to the same level or, decrease the growth. I would say, if you really decrease fertilizer, I do think that, you won't get the same growth at the minute. Now, everything I've been showing, though, is for the moment, the model is only doing grass only. So it's just grass. If you had clover, and we're going to do that in the future, so I don't have the result right now, but if you did had clover, that's a full different story, because an actual increase in temperature for clover would actually be very beneficial for it, because often it's a bit too cold in Ireland. That's why last year it didn't work that well at times, because it was too cold. So if we do get an increase in temperature, clover should become better and better in Ireland.
And the fertilizer you had in the presentation, Elodie, was 225 kilos?
Yeah, 225, because that was the limit. Yeah, last year we could go to. Yeah.
I'll throw that one there now, Eddie. Again, you can come in with one then. I suppose we have a TAMS list at the minute, Elodie, for a lot of different items. This is the new one now, I think, really, for it. Will there be a need for irrigation during the summer months in the near future? And we might have to add that to the TAMS list if there's anyone from the Department of Agriculture listening.
I would say not yet, no. And in terms of like, every time someone asks me that, it's like, where are we going to find the water? Like, because I do remember in 18, the problem was to put water in front of the cows. So if you don't have enough water to put in front of the cows, you're not going to have enough water. Well, in some farm, not everywhere, obviously. You won't have water to put into your field.
So it's more having that good silage quality for the month of June, July, August, September. And that's the one thing, Elodie, really stood out from your presentation. We're going to have more silage in June, July, August, September. And we're going to end up having to use better silage while we're still milking the cows at the start of the year. And that's a critical one. I suppose this year and last year are typical of that. So wet that they're on more silage. So silage 100%. Quality is one of the big adaptations I've taken from your talk this morning. Big
100%. And just to go back on irrigation, I know it looks like big decrease for Ireland because we're so used to be able to grow, to grow grass for the full year round without a drought. But it looks still fairly mild compared to what happened even in the north of France or Brittany and so on. So if they can still graze without, without irrigation, I don't think we need it in the near future. Anyway, I don't think that's something we need to focus on now.
So what you're saying is the new Irish drought wouldn't be called a drought abroad?
No, probably not. Yeah, 18 would be a normal year in my part of France, and I'm from the north, so it's just
I'll come in with two questions that have come in there, Elodie. One question is, do you foresee that there's going to be a need to reduce cow numbers, or now I think you answered that with your stocking rate.
I think it's not reduction overall; it's having the right number depending on how much you can grow. Yeah. So yes, if you're at the perfect stocking rate for your farm at the minute, and your grass growth is going to decrease in the future, you might have to reduce a small bit. Now, the model is more showing that we're going to have an increase of growth. So, it's really location dependent, and it's you need the flexibility in the system, but I would say you need it already now. So, yeah.
Yeah. And I think sorry, Seamus, I just kind of linked to that. Someone was asking, with the grass growth prediction model that you have at the moment, does it give predictions for multi-species swards and for clover-based swards?
So no, not yet. So as I said, we'll have the clover model, which is coming soon. So hopefully, I'd say next year, we might start to be able to do a prediction in grass clover, and multi-species will probably be our next step, but it's way more complicated to predict even than grass clover is already complicated. So putting in multi-species then is another level, and which species do you put in and all that. So for the future.
And I suppose you kind of answered this, and I think, Elodie, another question coming in there is, what is driving the predicted decrease in grass growth during the summer? It's just lack
of water and a bit higher temperature. So that means, it's soil moisture deficit, which is driven by a bit less rainfall, I would say, in the data which are there. And higher temperature means you get more evapotranspiration, so your SMD increase faster.
Okay, and the next question is probably very related to Eddie on the caller this morning. Would the environmental losses of nitrates to the atmosphere increase in the warmer scenario?
I haven't looked at it yet. The warmer scenario, I would say probably not. The more rainfall in the autumn, I would say probably yes. So it's more the rainfall which could have an impact. Now, I should have, but I haven't looked at the results because I do have them. So, but I haven't looked at that part of the model yet. I just have looked onto yield.
Yeah, and you're saying that we still need to go the same amount of fertilizer kind of as we're doing at the minute. You wouldn't be, with the adaptation, you wouldn't be reducing the amount of nitrogen essentially.
Well, not based on weather. Now, can we reduce it? If you put in clover, yes, you should reduce it definitely. It's that depends what you're calling adaptation on that one. If it's only solely based on weather, I don't see why. Now, once again, on an average year, if you do get a big drought in the summer, you should reduce your fertilizer that you would normally put in the summer because your grass can't grow as much. So you should reduce at that time of the year because your grass can't uptake your nitrogen. So
if moisture is deficient, it's
Yeah.
not going to grow the grass at that stage. Yeah,
Exactly.
perfect.
So in
And that's
that
what
case, you should reduce your fertilizer.
we have to acknowledge that farmers have reduced their chemical nitrogen use by a quarter since 2018. So huge reduction already have taken place. Do you want to go with a couple, Eddie?
Well, just a question from myself, Elodie, based on some of the, I don't know if I'm right saying multipliers, but the workings of your model. And you showed the increase in grass growth, on, particularly in the first couple of slides, at the shoulders of what I would call the shoulders of the grazing season at the moment. And one thing that doesn't change with climate change and intensive weather patterns is the day length and daylight. You know, we're still in the same location out from the sun. We're still at the same angle, and the world hopefully will stay spinning at the same speed. So I'm wondering what impact or relative importance has temperature and soil temperature in comparison with daylight when the days are getting shorter? I hope that's not too technical a question, and if it is,
I guess, no, but I guess that's why when you look at the data I've shown, April is really the big month which have a big increase, because you do have that increase of growth and your day length starts to be long. So that's where the cumulative effect, you know, it's so that's why the increase in April is way higher than your increase in January, February. Because January and February, you do have a small increase because it's slightly warmer. So I guess your soil temperature might be at 3 now, and they might be at 6 or 7. I haven't looked exactly to the number. So that means your grass can start growing a small bit, but it won't be that big exactly as you said, because day length is too short. Then in April, 1 or 2 degree increase in April means way more growth.
Yeah.
Okay, can I ask another one there, Elodie? I suppose maybe just in relation to some of the bigger dairy areas, is there any climate adaptation work being done in West Cork or Moore Park at the minute?
So I guess in pure adaptation, there is in Curtin's Moor, there is a multi-species trial that, you know, that we're hoping multi-species will start to be a bit more performing in terms of drought and things like that. So that would be one. And then there's a lot of work done on, it's a bit more mitigations and adaptation, but fertilizer timing based on weather. So I know Onyamore has a trial which is starting working on that. So that would be the two big one. And then I know John Finn still have a good bit of work on multi-species in Johnstone, I would say.
No, there's a bit of a technical question. Might not be your area, Elodie.
Okay.
I'll ask it anyway. So if not, just say no. Will there be suitable spray allowed to treat Drizzlera leaf spot in future, as none allowed at present, even though incidence seems to be increasing, especially in second cuts?
Absolutely no idea. So
Okay.
no, that's not my area. I don't know that, no.
So I'll take the question in relation to sprays and that as such. Okay. Do you want to go there, Eddie?
A lot of the questions are similar, coming up with more with adaptation measures and what work you were asking there, Seamus, again, about adaptation measures being implemented in the south of the country where dairy is very dominant of the sectors. I suppose just with that in mind, both my own background in the agricultural catchments program and with Elodie, I know she referred to it in a number of the projects that she's worked with. A lot of the people watching today coming from the advisory service are used to the Department of Agriculture in a scheme and enforcement role, but the Department of Agriculture do fund research like our own catchments program and like the projects that Elodie has alluded to there. And it's important to acknowledge that that's good work coming out in that respect. Are you aware of a focus or a drive for funding for research on adaptation measures as opposed to mitigation? And I know you said at the start mitigation is more important. We really have to do everything possible.
I'm not saying it's more important. I'm saying there's more work done on that.
Yeah. Do you think there's a change with increased emphasis on research into adaptation methods as opposed?
There's still a lot of money put on mitigation, which makes sense. But I think we're waking up since 2 or 3 years to realize that we need also to work on adaptation. And I guess the 2 projects I got funded 3 years ago, 2 years ago and last year. So it's really, and I don't know if there was that many projects before, which were, some might have had adaptation in them, but those one were really pure adaptation project. So I think, definitely there is a bit of wake-up call, I guess, or direction going in more adaptation. And like the idea of the first project on that big lit review will be to try to find where the research will go in the future. So I guess one thing which we'll have to work more, and I know there's a bit of research done on it at the minute, like it's, improve silage quality. How can we do that? That's not me, which is going to tell you how to do it. But I think there's going to be more work done on those kind of things.
And maybe follow on to that question, Eddie. I suppose the question came in there. What new research is required on climate adaptation projects described in your presentation, Elodie? So do we need to begin looking at how to address potential impacts such as new plant crops bred to abiotic biotic stressors?
Yeah,
a bit too specific?
No. I think, well, I would say they're probably going to do that in crops, definitely. That will be, I'm guessing that's one of the directions they will take in terms in terms of grass breeding. Yes, we'll have to have probably grass which are maybe a small bit more drought resistant, and diseases resistance definitely will be one of the two new traits that we might have to look at a bit more in the future. Definitely, yeah.
Yeah. And there's another one maybe just come in there in relation to multi-species swards. So I suppose, do you have multi-species swards, grass clover predictions for farmers with grass clover multi-species swards?
No, we don't have the prediction for that yet. No.
Okay, so it's based on grass.
It's grass only. Everything I've shown is grass. Yeah, I should have been more specific at the start, but everything for the moment is grass only.
And Elodie, one thing that struck me when you're going through your presentation there is, I suppose the stocking rate for Ballyhaise was less than 2.3 cows per hectare, and the optimum stocking rate for Oak Park was just over 2.3 cows per hectare. So I suppose for the vast majority of cows, which are 92 kilos of organic nitrogen per cow, that would mean that farmers should be stocked at someplace around 208 kilos of organic nitrogen per hectare in Ballyhaise, and about 214 in Oak Park. So that's under the 220 threshold in a lot of the country, as the derogation regulation at the minute. Would that be fair to say?
Yeah, well, on the so if you're growing as much as what if my model is right on your farm, that means you can, you should be probably slightly lower than the 220. Yeah. So now if you can grow more, that's perfect. Like, the model isn't perfect. And
the average growth stocked at less than a cow per acre.
Yeah.
Okay, Eddie, do you want to go again?
Yeah, Elodie, a lot of the adoption measures that you're mentioning there, they're nothing new. On-off grazing isn't new. Grass measuring isn't new. The prediction model is your work, and it is relatively new and it's been used. But just in your experience over, there's a very significant increase in focus on environmental impact from agriculture over the last 4 or 5 years. Do you think the adoption of these measures has changed over that time period? And I suppose, Seamus, I'll direct this question to you also in your job as a climate sustainability advisor, because Teagasc are putting a lot of resources into sustainability advice. Have we done enough to get these measures adopted? And what do you think the barriers are? Like when I go out at the weekend, I'm standing at the side of a rugby pitch and I'm talking to a lot of friends about rugby, and they're not coming up talking to me about mitigation measures. It's not the thing that's first and foremost in their mind. Whereas when I'm working in Teagasc and I'm dealing with people who are doing research on water quality and environmental things, we think everybody is engaged in it. Do you think there's a lot more work to be done? Are you disappointed with the uptake in the measures that are well established and around a long time? Or are we doing enough in the advisory side?
Yeah. Well, I would say we're never doing enough, but maybe a bit outside of my area, so maybe Seamus is better than me to answer that.
I take that one, Eddie. I think farmers deserve great credit. We have a target of reducing our chemical nitrogen by 26% by 2030. We are on the cusp of reaching that already. We're gone over 2/3 of all our slurry now being sprayed with low emission slurry spreading. Incredible feat. Historically, about 10%. The fertilizer sold in the country, half is straight nitrogen, half is compounds. Historically, the half sold as straight nitrogen would have been 10-15% urea type products. We've now gone over 50% in 2023 for the first time. We've gone over 50% in 2024. And of that, nearly 30% is now protected urea of straight nitrogen. So huge credit being given to farmers. I think the trick we're missing, Eddie, is it's like when I'm out at groups, farmers using protected urea working exceptionally well. You'll always hear about the person it doesn't work well for, and they'll tell everybody. But the question I always ask farmers at groups is, where it's working well, how many people have you told? And the answer, Eddie, is normally nobody.
Yeah.
So the question is to get the
Yeah.
farmers who are taking on these technologies. We need them on Team Agriculture, that they're telling 10 more farmers that this is what I'm doing and it's working well for me. That's the challenge. We need to challenge people who are doing the good work to help to spread it that bit more. And I suppose the other technology, simple ones like the amount of calves per suckler cow, that's increasing. The marginal cows and dairy herds, there's 15,000 less dairy cows in the country this year. So farmers deserve huge credit in getting. I suppose the big thing is 21 sustainability advisors like myself around the country. It's a contact sport. We have 500 farmers a year to get around to, which we are at the minute, but it's just time to get around to them all. But we need everyone in the industry, and they are really playing their part to play their part. If that answers your question, Eddie, sorry, in a roundabout way.
No, it does. It does, Seamus, and I apologise maybe if it came out of the question out of the blue like that.
Yeah.
But
Eddie, every opportunity is an opportunity to sell. So talk farming first, we can talk rugby.
Yeah. Well, we'll keep things social as well. Keep things social. Elodie, your presentation has been fantastic. It has been really enlightening, and it's always interesting when people are trying to predict what's coming in the future. And you have it there based on science, and we really thank you very much for what you've gone through. And I wish you the best of luck in continuing with that line of work. I think there's going to be no shortage of people with requests coming in for extra bits taken out of that. Seamus, thank you very much for helping with the questions. You make my job here very easy. It's difficult to read questions and ask questions at the same time. I can only do one thing. And finally, all this wouldn't happen without the effort put in the background by Yvonne Marr. She tirelessly and never complains, slaves away, and everything runs like clockwork. Thank you very much, Yvonne. Next week, we have a talk on the Farm Peat EIP. Caroline Lawler is heading up that program, and she's going to give an overview of the learnings, an overview of the program and the learnings that she has had from that. So that's at the same time, same place in a week's time, and hopefully the weather will be nicer. So on that, I wish you all a nice weekend. Thanks very much for coming along, and take care of yourselves.